We're going to start building a simple network that ranges or connect between two local area network. We'll start off by pulling out two routers, two switch, and two PC. And the next action we're going to take is to do the connection or cabling between the different devices. As we have all gone through, the type of cable that is going to be used between a PC and a switch is always a straight-through cable. Start by connecting from the PC end fast Ethernet port to the switch, any of the fast Ethernet port. And in this case, we are going to start making use of fast Ethernet 0/1. The next step, basically, we are going to start by connecting from the switch to the router. For connection from the switch to router, we are also going to make use of fast Ethernet connection, which is through the use of a straight-through cable too. Start by connecting. In this case, let's make use of fast Ethernet port 0/24 to be connected to router 0, which is fast Ethernet 0/0. Do the same for the other side of the network by making use of a straight-through cable from the PC to the switch and from the switch to the router. After you have done a connection, you can see that the link status from the PC to the switch will be active and green in color, which means that it is enabled. But from the switch to the router, it is still red in color for the link status. As by default, all interface on the router will always be in shutdown mode. That is why it's very important to do a no shutdown whenever you are configuring an IP address for the interfaces. Between the router, we are going to make use of a serial link. In this case, all router doesn't come by default with serial interfaces. Double click on the router. Simulate the router by shutting it off or by using the on-off button. On the left hand side, choose the interface card which you are going to use, which is a WIC-2T, which is a serial expansion interface card. Pull the card onto the slot that is just beside the on-off switch and power on the switch, so that we are equipped now with two additional serial ports for us to make use of it. Do the same thing for the other router on the other side. Switch off the router, pull the interface card, serial interface card into the appropriate slot, power on. Next, let's go back to choosing the cable to be used for connecting between the two routers. And in this case, we are going to make use of a serial cable. Click on the serial icon. Start by going from left, making use of serial 0/0/0, connecting to the other side of the router, which is serial 0/0/0. Take note that it is very important for you to take note of the interface that is being used, so that you won't configure the wrong IP address on the wrong interfaces. Another additional point to take note of is, in case you can't see the interface labeling on the topology, you can always go to option, preference, and enable the option always show port label. Make sure that it's ticked, so that at least you will see the port that is going to be used for your connection. After setting up the topology for the network, next we are going to assign three range of address for the connection of our network. On the left hand side, okay, basically we're going to make use of a class C address, which is 192.168.10.0, using the default subnet mask of 255.255.255.0 or 3255 and 10, which is a prefix of 24. For the serial link that is connecting between the routers, we're going to make use of a class A address, which is 10.10.10.0 with a prefix default subnet mask of 255.0.0.0, which is a prefix of 8. And on the right hand side of the local area network, we're going to make use of the class B address, which is 172.16, which is 172.16.0.0, okay, with a default subnet mask of 255.255.0.0 or prefix of 16. After assigning the range of address to be used for the network, we're going to start configuring the IP address. We're going to start by configuring the router, okay, or router 0. Double click on the router, go to CLI tab, okay, always answer no to the auto setup mode, press enter. You'll be in user mode, which is the first mode that you'll be in. Type enable. Okay, it will bring you to a router prompt with a hex sign, which means that now you are in privileged executive mode. Okay. If you are not sure what are the interfaces that you're going to work with, okay, basically you can do a show run or show running config here to take note of the interfaces that you're going to make use of on this router. Press enter. Okay, basically the interfaces that is available on this router are fastnet 0/0, 0/1, serial interface 0/0/0, serial interface 0/0/1. Okay, 4 type of interfaces, 2 fastnet, 2 serial. Next, we are going into the configure terminal mode, okay, or configuration terminal mode, which enable us to do different types of configuration to the router. We are going to start off with assigning a host name, okay, to the router, and in this case we are going to call this router router 0 to uniquely identify, so that in case we are opening several command line interface for different devices at the same time, we know that which router are we working with. You can see that the router prompt basically now changed to router 0. So as a default, whenever you get to work on any Cisco router or devices or switches, okay, always configure several parameters as a prerequisite: the host name, the enable password, enable secret password, line console password, and line VTOL password. We're going to assume a level 2 enable password of Cisco. Start by doing enable password followed by the password Cisco. Okay, and we are going to do a level 2 enable secret password, okay, which is, let's give it a password of class. To take note that, okay, if you have enabled an enable password Cisco, when you do a show run, okay, it will be shown, so that anyone that is just standing behind you looking at your show running configuration command, they will be able to know your level 2 password that you use to access your enable or your privileged executive mode. That is why it's very important for you to do an enable secret password to hide your password, so that only you or the administrator of the network will know what is the password to gain entry to your privileged executive mode. Okay. Always take note that your enable secret password will always override your enable password. Okay. That means that you're going to take precedence over your enable password. Next, we are going to do our line console password, okay, which we start off with line console 0. The reason why is 0 is because on any Cisco devices, router or switches, there is always only one port, and the number always start off with 0. Press enter. You'll now see that the prompt changes to config-line, which means that you are now in the config terminal, sub mode, line mode. Okay, do the password command followed by the password we're going to choose in this case, which is Cisco. Press enter. Always follow up with another additional command, which is login, okay, to tell the router that anyone who try to access the devices, the router or the switches through the console mode, always enforce a password prompt. Press enter, and that's it. You have set your password for online console. That's it. Next, we're going to do our line virtual terminal, which is line BTY 0 to 4. On most router, okay, basically we have only 5 virtual terminal port, which is 0 to 4. Press enter. Same. Do a password Cisco. Press enter, followed by a login prompt. Okay. And that's it. Okay, you have set your host name, your enable password, your console password, and your BTY password. Do this same configuration for the rest of the devices that you see in this topology, which in this case your router 1, your switch 0, and your switch 1. We will go on to do on the router 0. No. Go to enable mode, config T mode, okay, and start by doing your host name for router 1. Do your enable password, which is Cisco in this case. Your enable secret password, which is class. Line console 0, password Cisco, login, exit, followed by a line BTY 04, password Cisco, login. Okay. There is no right or wrong in the sequence of your configuration. You can do any portion of your configuration at any point of time. Okay, then exit. Now proceed to switch 0. Okay, go to CLI. Okay, enable config T, host name for your switch, which is switch 0. Okay, and one important factors that you need to take note of for the switch. Okay, most of the switch that Cisco produces, okay, you can take note that on the router itself, you always do a line VTY 0 to 4, which means that there are 5 virtual terminal port, okay, for remote access. Okay, but for a switch, okay, if you do a show run at the privileged executive mode, take note of the fact that, okay, the virtual terminal port ranges from 0 all the way to 15. That is to mean that if you did a line virtual terminal VTY 0 to 4 with the password command, you're only going to protect the first 5 port, but you're not going to protect the rest of the port. So always remember, on the switch or any devices that you see, you always do a show run to see how many virtual terminal port you have. Okay. So let's get back to our configuration. Enable password Cisco, enable secret class, line console 0, password Cisco, login, exit, line BTY 0. Okay, just now as I mentioned, okay, it doesn't end with 4, but it ends with 15. Okay, password Cisco, login. Okay, exit. Okay, exit. Do a show run to verify your configuration. Let's do again. Okay, your host name, which has been configured, your enable secret password, which is been hashed by MD5 algorithm, which is not readable to you, the enable password, which you can see it here, your line console password, your line VTY password. You can see that I've safely protected from port virtual terminal port 0 all the way to 15. Do the same thing for the other side. Okay, on switch 1, enable config T, host name, switch 1, enable password, Cisco, enable secret class, do a line console 0, password Cisco, login, exit, line VTY 0 to 15, password Cisco, login. As and when if you think that you need to change any password, okay, always know that for most of command on Cisco devices, basically you can just override it. Let's say in this case, let's say for line VTY 015 instead of Cisco, I'm going to change the password to Cisco 1. Basically in the line VTY line mode, okay, basically you just type the password again, followed by the new password that you want, which in this case let's set it to be Cisco 1. Okay, enter. Okay, and that's it. You have changed your password. Okay, Control Z to go out to your privileged executive mode. Do a show run. Okay, your host name, enable secret password, enable password in clear text mode. Okay, your line console password. Okay, you can see that in this case for line VTY password, I've safely changed it to Cisco 1. And that are the prerequisite or those commands that you must do for all the devices. Okay, default configuration that you must at least do for all your devices. Next, we're going to start configuring our IP address, okay, for router 0. Okay, do an exit. Okay, let's configure our fast Ethernet 00 interface first. Do an interface command followed by your fast Ethernet 0/0, which is the interface that connected to the switch on my local area network. Okay, assign the first IP address of the range of address that I'm going to assign, which in this case 192.168.10.1 IP address, 192.168.10.1, followed by the subnet mask, which is in this case 255.255.255.0. Do a no shut. Okay, you can see that now, okay, the link has been enabled, it has been turned to green. Next, exit. Okay, we'll go on to configure our serial interface S000. IP address, which in this case let's use the first IP address 2 for this router, which is 10.10.10.1, followed by the default subnet mask, which is 255.0.0.0. no shut. Okay, to take note that, okay, on this side of the link, which is a DCE link, okay, you must provide the chord rate so that, okay, one person on one side, one router on one side of the router will need to control the speed as to how the data speed is going to be communicated. Okay, so on this side, let's do a crop rate 64,000. Okay, enter, and that's it. Okay, to take note that the link will not be up yet, because we haven't configured the other side of the router. Let's go on to configure the other side of the router. Okay. Interface, let's do our fast Ethernet interface first. Interface FA00, IP address, which in this case we're using a class B address 172.16.0. Let's make use of the first IP address 2.1, subnet mask 255.0.0, which is the default class B subnet mask. Enter, do a no shut. Okay, you can see that the link status has been enabled, which actually turns to green. To exit. Okay, now we're going to configure our serial interface 000. Okay, IP address. Okay, which is in this case is the second IP address, because we have made use of the first IP address on the other side of the router or on the other side of link. Always take note that you cannot have duplicated IP address in the network. Okay, because each and every interface or devices are supposed to have a unique IP address, so that your data or your communication can take place among them. So in this case, we will make use of second 10.10.10.2 default subnet mask, which is your class A 255.0.0.0. Enter, no shut. Then you can see that the link has now been enabled and it has basically become green. Okay, close your router 1 CLI screen. We have configured our IP address for our router. Next, we'll go on to configure our PC, so that we can start doing a communication test, which is doing a ping from the PC to the router. Click on your PC, go to your desktop tab, go to your IP configuration. Since you have made use of 192.168.10.1 for your first address, okay, let's make use of the 10 address for this PC, 192.168.10.10. Okay, you can see that once you click on subnet mask, it's automatically filled up with the class C default subnet mask. Okay, one important parameter to fill up. Okay, since we are going to connect, we are not going to do a topology for a LAN, which only involve one side of the network. We are going to do a network that involve different LAN that are connected together. That is to mean that we must allow our traffic to go out of our local area network to go into our wide area network, which is in this case between the router. Always take note that the default gateway is the IP address of the first interfaces that is connected to your external network, which in this case which is the fast Ethernet 0/0 IP address of router 0, which is 192.168.10.1. This is the point where external traffic will go into your local area network, or your internal traffic will go out of your network. That is the definition of your default gateway. Okay. Basically, a default gateway is like a door or an entrance or an exit, whereby your internal network will go out to the external network, or any traffic from external network will go into your internal network. Okay, so it's 192.168.10.1. Okay, so that's it. You configure IP address for your PC. Next, we go on to configure IP address for the PC on the other side. Double click, same, go to desktop, deconfiguration. In this case, we're going to make use of our same. Let's make use of the 10 IP address of the range of address that we have given, which is 172.16.0.10. Click on the subnet mask. It's automatically filled out with a default subnet mask of class B. Okay. Then for the default gateway, always remember, is the first interface that is on the router that is connected to your local area network, which is in this case your router 1 FA00 IP address, which is 172 192.16.0.1. Okay, close it. Okay, after you configure, okay, you can start doing some testing. Okay, you can actually from your PC ping all the way to the IP address of your router, which is in this case your default gateway. Okay, and you should get a reply, and that is a successful communication link between your PC and your router. Okay, there is an additional configuration that we need to do for the switch. Okay, let's say assuming a scenario whereby you can't ping the router. Is it a fault on the cable between the switch and the router, or is it a fault on the switch, or is it a fault on the cable between the PC and the switch? At the moment, from the PC we can only ping directly to the router. That is why even if the ping failed, we won't know whether which portion of the network is having problem. Is it the cable, is it the switch, or is it the cable between the switch and the PC? That is why, okay, we are now going to assign an IP address to the switch, so that we can also try to ping the switch to determine whether the switch is alive. Okay, if we can ping the switch but we cannot ping the router, it means that the link between the switch and the router is down, but not the link between the PC and the switch is down. This is basically some ways of troubleshooting, or to narrow down our troubleshooting, or to narrow down the fault that we're going to search for. Double click on the switch. Okay, go into your config T mode. Okay, in order to configure IP address on your switch, okay, basically we are going to assign an IP address to your VLAN 1 interfaces, okay, which is the default VLAN that is always configured on a switch. Start by doing an interface, followed by the keyword VLAN 1. Press enter. You're now in your sub interface mode. Let's make use of the second IP address of the IP address range that we're given, okay, which is 172.16.0.2, followed by the default subnet mask. Enter, no, shut, and that's it. We have configured IP address for the switch, so that instead of pinging the router now, we can also try to ping the switch to narrow down our range of fault finding, whether is it the switch is having problem, or whether is it the router is having problem. You can do a test, okay, by clicking on the PC again, do a ping to the switch 172.16.0.2, and wait a while. Okay, you can get a reply. It means that the switch is now having IP address 172.16.0.2. Okay, do the same thing for the other side. Log in using Cisco, enable plus config T, interface VLAN 1, IP address. Okay, in this case we're making a class C 192.168.10. Let's use the same. For IP address assignment, always be systematic. Since we are making use of second IP address for the other side, let's make use of the second IP address for this side too. Use the default subnet mask. Okay, no, shut. That's it. You configure IP address for the switch on this end of the network. Okay, let's try to ping all the IP address that I've given. Okay, let's ping our 192.168.10.2, which is our switch. Okay, we have get a reply. Let's pin our default gateway, which is the fast internet interface on the router. We have get a reply. Let's pin our serial interface. we get a reply, means that the connectivity is all up. Let's try to ping the other side of the router, which is router 10 interface, which is in 10.10.10.2. With a request timeout. Why? Because we haven't enabled the router to tell each other about the network on their end. It's a similar scenario whereby, okay, I have you as a friend, but do I know how to go to your grandfather or grandmother house if let's say they are staying in a different house? That is why we need to enable certain configuration on the router to allow them to tell each other about their network that is connected to each other. That is to mean that, okay, whatever place that I want to go, okay, if you knew about it, okay, you must tell me about it. And that is what we're going to do today also. Okay, basically we're going to do dynamic routing protocol, which we have learned in one of the chapter in network layer. Let's log in, enable class, okay, config T. So the command that is going to enable us to pass address information between the router, to enable them to know who are connected to each other, okay, is the command router, okay, followed by RIP, which stands for routing information protocol. At this point of time, we are not going to learn about the rest of the routing information protocol. We are going to learn about the first one, which is a routing information protocol, which is RIP. Okay. So basically start off with router RIP. You can see now you are in the router sub mode. Okay. What are the network that's connected on router 0? Basically is your 192.168.10.0 and your 10.10.0 network. Okay. To your network command, okay, the command to use is network. That means that I'm going to tell what are the network that is going to be connected to this router itself. Okay, the command network followed by 192.168.10.0. Press enter. The other side, the other link that is connected to the router, okay, 10.10.10.0. Press enter. And that's it. Okay, we have tell this router who are the network that is connected to each other. Do the same thing for the other side. Enable class config T. Okay, on this side of the network, okay, basically what are the network that's connected to the router. Do the same command, router RIP network 172.16.0.0. Enter. Network 10.10.10.0. Okay, that's it. Okay, we have enabled the router to know about the network that is connected to each other. Okay, and now if you try to ping each other, just now when we try to ping the other side of the router, basically we are not able to receive any reply. Let's do it now. You can see that now there is a reply, even though router 0 doesn't know about the network on the other side. Let's do a ping again for 172.16.0. Let's say the PC on the other side. Okay, you can safely get a reply. What happens if you have an additional network which is connected on the router on the other side? Let's do a simple simulation. Pull out a PC. Okay. From PC to router, basically we're going to make use of a crossover cable, fast Ethernet to fast Ethernet 01. Let's assign it the IP address of 192.168. Let's say 20.0/24. Okay. Start by doing all the necessary configuration on your router and your PC. Okay, interface FA0/1, IP address, let's assign it the first IP address of that range that we're given. No shut. Set the IP address for your PC. 192.168.20.10. Okay, make sure you enter the default gateway, which in this case your FA01 interface 1. Okay, after we have configured the second network that is going to be connected to router 0, okay, let's click that PC2. Okay, the IP address we have configured. Okay, let's do a ping, okay, to the default gateway, which is the fast Ethernet 0/1 interface on router 0, 168.1, 192.168.20.1. Okay, you can get a reply. Okay. Even if you're trying to ping your internal network 192.168.10.0.1, you should be able to get a reply. Try to ping a PC, you are able to get a reply because you are on the same side of the network. But what if you're going to ping the other side of the network, which is 10.10.10.2? Okay, you're going to get a request timeout. Okay, why? Because just now when we did our routing or dynamic routing protocol, we've only enabled network 192.168.10 and the network 10, but we haven't enabled our 192.168.20 network yet. Okay, let's close the screen, go back to the router. Okay, do a show run on your previous executive mode. Okay, you can scroll all the way down until you see the portion router read. Okay, just now as mentioned, we have only did our network for the class A, which is 10 network, and our 192.168.10 network, but we haven't did our network command for 192.168.20 network. So we are going to do it now, so that you enable us or enable the router to pass routing information between themselves, or to pass the network addressing information between themselves, to enable them to pass traffic to each other or to remote network. Go to config T, go to router read again. In this case now we're going to do our network 192.168.20.0 range. Press enter, and that's it. We are ready to ping the other end of the network. Go back to previous mode by pressing Ctrl Z, show run. Okay, you can see your router read. You have the third line. Okay, click on your PC2. Okay, now you can safely ping the other end of the network. And that is how you enable the routers to communicate between themselves, to enable to share addressing information, okay, without knowing about each other directly connected network, which is in this case on the left hand side of the network. I have 192.168.10.0, 192.168.20.0, but initially router 1 doesn't know about it. But only after we enable routing information protocol or the dynamic routing protocol between the router, they are able to tell each other about the network they are able to reach. And that is how router actually works in the networking world, by enabling routing protocol to allow traffic to flow from one network to the other network.